Out of the Toyota production system, just-in-time evolved. The just-in-time system focuses on creating what is needed, when it's needed, and in the quantity needed. What was unique about the just-in-time system is that it covered manufacturing, procurement, distribution, and all aspects of subcontracting to suppliers. In essence, it was an early attempt to extend continuous improvement beyond one's own organization, while still reaping the benefits internally. As time went on, just-in-time evolved into what we know today as lean manufacturing. Since just-in-time was such a powerful strategy for controlling inventory and improving operations, it only makes sense that this pillar would be a critical piece of a lean organization. As a reminder, lean is a continuous improvement strategy that a company embarks on to maximize customer value and minimize waste. One of the key focuses in lean is the removal of waste. To do this, an organization must be able to identify, reveal, and remove different forms of waste. Pull systems, as you may have guessed, are a very effective way to do just that. As we've learned, pull systems build to demand. One way to facilitate this is to reverse the flow of information. In a traditional push system, forecasts and schedules are the driver of production. However, in a pull system, nothing begins until an order shows up. That order then drives the production process. In this situation, the downstream operations or process steps pulls materials and services from upstream process steps, beginning with the customer order as the driver or trigger to begin. When this occurs, just-in-time becomes a reality. In addition to this, as products or services are created based on real demand, waste that is normally hidden in a push system begins to surface, and this gives organizations the opportunity to deal with the waste and improve. As various forms of muda are removed from an organization, lean management becomes a real possibility. Before we move into the implementation of a pull system, we need to first understand three absolutely critical aspects of the system. To do this, we will use the analogy of a stream to better understand flow, learn how customers are not just external to an organization, and we will look down how flow occurs in an organization. With this in mind, we'd like to ask you a question that you can answer in the community or the upcoming assignments section. What do you think the three most important aspects would be in your conversion from a traditional push system to a demand-driven pull system? We look forward to reading your responses, and we'll see you in the next module. Much like the flow of materials and services in an organization, a stream flows from upstream to downstream. As water flows through the stream, it moves rapidly to its destination. But if rocks or other blockages exist, the current will sometimes run slower or even halt to a complete stop. Imagine this water as value flowing through your organization. The goal is to get it to flow freely from order to customer. Because that value is at the mercy of your processes, you must find ways to facilitate a healthy flow of materials. In a pull system, flow often starts with a Kanban system and progresses to true one-piece flow. This, however, can only occur if forms of waste like transportation, waiting, inventory, and defects are eliminated. Given that these forms of waste will surely surface as you move from push to pull, it is important that you control the rate at which your products or services flow. This is done with two pieces of data. cycle time, which documents the actual rate of flow, and takt time, which refers to the rate at which products, information, and/or services need to be completed in to keep up with customer demand. In other words, the rate you need to flow at to keep up with demand. It's important to note that different products will flow differently, and because of this, your production lines will also need to be leveled to create a smooth flow. Whether in a factory, office, or service environment, your people, machines, information, and materials must flow together with standards in place and minimal waste. This will create the smooth flow of your stream and the most effective pull system possible. We'll see you in the next module. As we've learned, a pull system is based on real market demand, not schedules, forecasts, or estimates like a push system. In an effort to facilitate this process more effectively, it is very important to understand that customers are both internal and external to an organization. In a pull system, the next customer is the next downstream process step. To be more specific, each downstream process step is a customer to the previous upstream process step. In a push system, inventory is pushed to the next process step as soon as they are completed, even if the downstream customer is not ready for items. In a pull system, however, items are not produced until a downstream customer signals the upstream customer that they are ready. This prevents overproduction because it produces only to the customer demand. Much like a supermarket, customers retrieve what they need and the shelves are replenished based on that demand. This process is often facilitated by a Kanban card. The Kanban acts almost like a currency. Operators of a downstream process go to an upstream supermarket and withdraw using a Kanban. The Kanban then moves from the empty space in the market to produce or procure and refill the supermarket shelves. One important objective that the Kanban system helps fulfill is the control and management of production and inventory. By doing this, a company can lower their inventory to the absolute minimum amount needed so that they can avoid overproduction and prevent the buildup of excess inventory. This also prevents the need for holding large amounts of inventory to buffer your demand. We'll learn more about the Kanban system in future modules, and we'll see you in the next module. When looking at the production of materials or information, it is important to understand how flow occurs. With this in mind, we can break the flow of production down into 4 general stages: wait points, move points, processing points, and inspection points. Wait points, also known as retention points or queue points, are points in a process where items are retained for various reasons. This could be for stocking, awaiting move, awaiting processing, or simply just staging. Wait points generally take up a large portion of a process and can provide significant opportunities for improvements. When wait points are reduced, lead times go down. Next, we have move points. These are sometimes referred to as transfer points or transportation points. Move points are the points in a process where items or information are moved from one point to another. While these points don't generally take too long, They are, in general, the second biggest opportunity for improvement in a process, and they can help reduce lead times when improved too. After move points, we have processing points. Processing points are the points in a process where value-added activities occur. In other words, these are activities that transform a product or service from one condition to another, are done right the first time through, and somebody is willing to pay for them. Processing points do not take up a lot of the total lead time in a process. In fact, they make up the least amount of time. Since these activities are directly related to the transformation of materials or information, many people often make attempts to address these activities first by bringing in new tools, machines, or resources. With this in mind, it is often a much better approach to look at these types of improvements last and first deal with improvements related to the elimination of waste. The final point we alluded to was inspection points. Inspection points are those points where materials or information are inspected and defects are removed. In a pull system, inspection points are built into each operation so that defective parts do not proceed from any point where a defect occurs, while downstream internal inspections still occur to ensure no defects have slipped through. This is really only a safety measure. Mistake-proofing devices like poka-yokes are built all through the process to catch errors and prevent defects. In addition to poka-yokes, on-on lights, trained workers, and standardized processes are in place to support the prevention of defects. This is all part of the Jidoka pillar that helps build quality into an organization, or in our case, the pull system. As you've learned, eliminated wait points can oftentimes make the largest impact on improving wait times. When this occurs, a process can often move from frequent stop-and-go production to a much more efficient process-and-go production environment. As you can see by this very basic process-level example, when wait points are improved, the process becomes much more efficient, effective, and lead times are reduced drastically. With this very basic breakdown of a process, we can now start to see how we will begin to make things flow. We'll see you in the next module.